Welcome all. Welcome to the Democracy Firewall Hackathon. Our smartest information, protect free speech. This is an initiative from the Council of Europe, and let me start by saying that you are already winners. You've been selected from a long list of concept notes, and I can say it was not easy. And let me start by introducing myself. My name is Hugo Espinosa. I am the founder and head of operations of Kreativdistrikt. If you want to follow us for updates, and we'll be posting a lot of information as well as photos from the event, here are the links where we post regularly stuff. So please follow us there. I am very pleased to have done by a number of hackathons with the Council of Europe, and this year we have this opportunity of help and create this hackathon for about outsmart disinformation, as you well already know. So now, teams, can I have your hand? Let's start with Danatara. Can you raise your hand? Do we have somebody here? Awesome. Truster, do you have one of your teammates here? No one from Truster? PT, they're missing out then. How about Radar? The team. There you go, we got it. Okay. Echo Breaker, do we have somebody from Echo Breaker? Hey. Gecko team, are you here? Some are missing. PT. How about France and Portugal? For the win, I assume. Awesome, good stuff. Meta and Go, where is the people from Meta and Go? Awesome, good to have you here, guys. Sunflower, do we have somebody from Sunflower? Great, good to see you, good to see you. Democracy Defender, do we have anybody from Democracy Defender? Yes, we do. And finally, Dyspoxia, the first one that I've had today. Good stuff. That's great. I'm very happy to have you all here. As you know, we've closed with the registration phase. It was very complicated, but now let's move on to what with this main event. You know that we had over 280 ideas submitted by residents of the Council of Europe member states. That it was very difficult. We had a lot of homework, but the important thing is that your ideas stood out. So these are the top ideas in our eyes, the ones that we want to work with. Now, let's get started. You're going to be competing with the opportunity to come to Strasbourg and win 3,000 euros in a prize pool. Of course, contributing meaningfully to the fight for democracy in a time of uncertainty. That being said, this hackathon is all about protecting democracy in the digital age. You'll be working in 4 key challenges, which is expose malicious infrastructure, increase algorithm transparency, promote reliable information, and strengthen society resilience. That's great. There's 2 main phases of this hackathon. This being the first part, which is the warm-up phase. This warm-up phase contains 3 sessions, this being the first session, which is focused on computer science. We will have 2 more sessions. The second session is focused on empathic and feasibility, and it will happen next Monday, 9th of June, at the same time. So it's 4 p.m. Central European time. So please adjust for your time, but you have already received the calendar for that event. Remember that you will receive instructions for your first deliverable that day. So you will have to complete that deliverable by the 18th of June, which is 2 full days before the hackathon. Okay, so just to be clear, next Monday we will release the instructions for deliverable 1, which you will have to complete by the 18th of June, 2 days before the hackathon. Okay. That being said, the third and last session will be focused on law and compliance and will take place on the 16th of June. Where will this take place? It will happen in the Council of Europe headquarters, the Palais d'Europe, and the Avenue of the l'Europe, Strasbourg, and I just murdered that phrase in French. Let's watch a little bit about the agenda for the day of the hackathon. This is the agenda, but might change. Just FYI. We have a parent event that we will be contained within. But what's going to happen? You need to arrive to these headquarters at 8 a.m., where the registration will open. Later, we will have welcome and opening remarks. Finally, we will have an introduction to the hackathon and introduction of mentors. And then there will be teams live pitches. Just FYI, there will be a large audience. I'm not going to go any deeper. I'll leave mentors to discuss that with you Monday. After that, we will have the beginning of the hackathon, which you will start working. At midday, we will have a lunch break, and finally, teamwork will continue and mentorship sessions. What happens is that mentors will introduce themselves to all of the tables, and then they will go and support you with any questions you may have. So my suggestion is to write down all of the questions that you have pertinent to the three topics, which is law, creativity, and computer science. And then when the mentor arrives, if it's one is not they're busy with another team, you can pose their questions. After that, we will have the final sprint at 6:30. So you have to polish your project. And finally, at 7, we will have your deliverable completed. So pencils down, because I need pack all of your final deliverables, because then you will participate on the Dragon's Den style of competition. I'm not gonna go deeper today on the Dragon's Den information, because I know that you all want to know how it's going to happen, what are the rules, etc. But this is going to happen on the third warm-up phase. So please remember to attend. Right after the Dragon's Den, we will have a reception at the Parliament Bar. Meanwhile, the judges will be deliberating on who will be the winner of this hackathon. Finally, we will have a award ceremony, and we will have a concert for you. Today's mentors, unfortunately, I have to say, Amaury Correa, he cannot attend this meeting because he has a family emergency, but he was so kind as to share his slides, and I will be sharing that with you. So please go through all of them as well. But now I leave the word to Thomas Lampert, who is a professor of computer science at the University of Strasbourg, specializing in artificial intelligence. After his presentation, we will have 10 minutes for Q&A. So please, during his presentation, if you have some questions, write them down, not on the chat, but on your piece of paper or somewhere else. And then if you like, you can ask him. Thank you very much. Thomas, now you can present.
Hello, thank you very much, Hugo. Hello, everybody. Looking forward to meeting you all in a couple of weeks here in Strasbourg. But until then, I'm going to give you a little warm-up session. So I understand that the teams are quite mixed in expertise. So I'm going to give, for those who are not really trained in AI or the computer science field, I'm going to give you a little introduction to what is AI, especially ChatGPT. Yeah, this is the current trend. And this will give you some ideas about how AI text and images can be generated. Of course, we can discuss more in depth about certain aspects of that, maybe in the questions after here, but in the day. And then Amaury has sent the slides for his part of the talk, which are very interesting on botnets and how to detect disinformation online. So here I'm going to start really in the basics so that everybody's up to speed and at the same level and things like this. So AI, or we often refer to it as machine learning, is a field...
We cannot see your slides, by the way.
No, sorry?
No, we only see the share screen.
Okay, let me just... And now? Now?
Yes, now we can.
Okay, sorry about that. Okay, so machine learning. So current AI, and I say current because obviously this field is evolving very rapidly, as you're aware. What we want to make clear at the beginning is that this reproduces the results of our cognitive intelligence. It doesn't reproduce the cognitive process. So obviously we have an input, some images, some text, we read some things like that, and we think about it, and then we act upon it or have a decision about it. And this process is well studied, but perhaps still a little parts of it are unknown. And AI systems try and recreate this input from text or whatever, and the decision that might be made. But in the middle, there is something that doesn't resemble the way that our biological processes process information. So we want to make that clear from the beginning that artificial intelligence is not intelligent. It is, and we're going to see that more in detail in the coming slides. So a very, very high-level overview of what machine learning is and what the process is. We're going to look at these bits in a bit more detail, but basically you've got data going in. You're all aware of that, whether it be text from the web or images and things like this. And then we have what's called an AI model, and I'm sure you've all heard about neural networks and deep learning and things like this. So this is where that model occurs, and I'm going to explain those a bit more in detail in the coming slides. And then the model gives some output, a prediction, I say here, but it gives some output. And when we're training this model, the important thing is, because this model starts off completely at random, and we're going to see what that means, we need it to align with what we want it to predict. If we show it an image of a cat, we'd like it to predict that it's a cat. If we give it some text and we want it to complete the text, we'd like it to predict what is the next word in the text. So while we're training this model, we take the outputs and we compare it to what we know about the data. And if it's incorrect, we change the model in some way such that the prediction gives a good output. So that's the general overview of an AI model, the way it's trained, and then afterwards we remove the feedback loop and we just put data in, we use the trained model, and we get a prediction out that may be useful to us. What does this model look like? So as we've mentioned, that they are generally based on neural networks nowadays, and a neural network is something that this is what we design them as in this kind of image where we've got nodes and we've got lots of connections between them. And this might look a bit complex and abstract and how does this work, but basically all of these lines between the nodes are just multiplications of numbers. So each line is a multiplication of a number, and the blue nodes on the left, I don't know if you can see my cursor here, the blue nodes on the left are numbers that go in. So we've got numbers that go in, they get multiplied by numbers here, and then you sum them together, all these connections that are multiplications, and then you repeat the process, okay? And we notice we have another output bit here. So this could be a class, this could be a cat and a dog. And if this number here ends up being high, then we could say that the image that goes in is a cat. And if this output here ends up high, then we could say that the input was a dog. So although deep neural networks and neural networks, etc., might seem very complex, essentially that is all they are. There's lots of multiplications of numbers, there's some additions and then more multiplications, such that you guide some input to give a certain output, and then you can predict something. And this feedback loop that I talked about before is how you decide which numbers you multiply things by, such as you get a high value here or a high value here. That's all that a machine learning process is in ChatGPT, for example, or an image classifier. So each of those little neurons, as I mentioned, they're multiplications. So we call them neurons. They're not actual neurons that like in our brain, but we use a mathematical model of a neuron, and that's how neural networks were developed. So of course, a neuron is a very complex biological structure that sends information to other neurons, etc., etc. And we say, okay, we have an input here, which can be a value of an image or a text or something, and we multiply it by some numbers, we add them together, and then it gives an output, and it passes it to the next neuron. So all of these lines going here is a neuron, and then it passes to the next neuron. So just to make it clear, everything within that are multiplications of numbers and some summations and little functions. Of course, we do that because our data are numbers. We might think of images as nice, colorful things and text as beautiful prose, but behind that to a computer, an image is a matrix of numbers. So you've got some values in certain positions, and they represent the light in that position. If we're talking about images, in text, you have a word, and the representation of that word is a number to the computer, and therefore it could be entered into these inputs to the neural network and multiplied by numbers, such that you guide the output to, as I said, be high in one sense for one thing or high in another sense for another thing. So all a neural network is the input of numbers getting multiplied by other numbers in a slightly complex way, but essentially that's all that's happening. And the output, whether it's a cat or whether it's a dog, depends on where the high value is at the end of it. Of course, we need a load of data to train a neural network. So often with images, we might collect lots of examples of bananas and we give them the label bananas. So this is a supervised classification task. In this sense, it's supervised because we know the label that we're looking for. And we might have a load of images of another type of class that we're trying to classify. And then we can train, as in update those numbers in the neural network, such that when you see something that's green in a round form, the output of one of those nodes is going to be high. And when you see something that's yellow in another form, the output of the other node is going to be high. And that's a classification. And that's made a classifier, trained an AI model to classify images, as is illustrated here. However, now this was how AI was done up until X number of years ago. I can't give you an exact number, but let's say 5, 6 years ago, when ChatGPT started getting known in the research field, or at least those kind of models. The big problem was that we need loads of data for this. We need lots of images, and we need lots of labels for the images. And it's very hard to get these labels. Now, we can get lots of images, they all exist on the internet. We can get lots of text documents, they all exist on the internet. But how do we have the label to those images? That's very difficult. So people started to think about how we can learn something from the data without these labels. And this was the key to where we are now with AI. Because what we can think about is we have the data itself, and we had before labels that we had to give as a target during the learning process. But now we could use the data itself as the target in the learning process. What we could do is we could cover some of the image and say, okay, I show you this first part that's uncovered, predict for me the value of this pixel and this pixel and this pixel, etc., etc. And now what we're doing is we're creating a task that allows us to learn something, but without having to label the data, because our task exists already in the data. This is what we refer to as self-supervised learning, and this is the basis of how these ChatGPT models were trained. I'm using images as an example because it's easier to come across, but you can imagine a sentence with words, and we cover some of the words, and we ask the model to predict them. So even you could see here, you could see some pattern in these numbers perhaps, and you can start predicting what would the next numbers be, and it would recreate the image of an apple. So these are self-supervised models, and they allow us to learn from huge amounts of data because all of this data exists online. We don't have to label it, we just have to collect it, and we can use to train these models. So these are generative models because they generate data. And this is exactly how ChatGPT works, for example. So in language, what we can do is we can take sentences from books or from the internet, and we can remove words from them. We can ask a model to fill in the words that is missing. And that's exactly how these GPT models are trained. And this allows the model to learn the statistical distribution of the data. Now what that means is, if I show it I am a virtual, and we remove the word and it learns to predict assistance, it's learning. If we show many sentences and we ask it to predict many hidden words, it learns the statistical probability of which word is likely to occur next in a sentence. So you can imagine afterwards we can use that to generate new sentences. So, as I mentioned, this is how we get to models like ChatGPT. So ChatGPT is a generative pre-trained transformer. So it's generative. We've explained that in terms of it generates data. It's pre-trained. This means that it's already trained on all of this data that we can hide words from, and then it learns the statistics of the data in order to predict it. And it's a transformer, and this is a special form of the neural network that I introduced at the beginning. So there's a bit more. We can see here, here's the neural network we saw earlier. Yeah? This is trained on lots of textual training data in exactly the way I said earlier, hiding words and asking it to predict it. So it learns the statistics of the data. We have a few other components in a ChatGPT model. We have a prompt, which is the input. This is the question that you type into the model. And this goes through certain tasks. And I'm going to explain those a little bit because this also gives you an idea of how these models work and how they are strong and also discloses their weaknesses. So one is the text tokenization. This is a technical word. It just means how the text is broken into little parts. Like we think about text as letters and then words and then sentences, etc., etc. ChatGPT doesn't think about text like that, and we can expose how it thinks about things in the next example. So this is a little conversation I had with ChatGPT a few months ago, so I don't guarantee that it still works, but because ChatGPT gets improved. But for example, if I ask it a relatively simple thing, ChatGPT is very intelligent, as people argue, and can solve many tasks in the world. I ask it how many of the letters F there is in the word fapping. That's a very English word. The answer is 4, although I'm pretty sure there's only 3 letters in F in the word fapping. I asked it the same question again. Now it tells me there's 2 letters in the word F. This is a bit baffling because ChatGPT is very intelligent. Why is it giving me 2 different answers to the same question if I ask it twice? I then argue a little bit. I try and trick it and I say, no, there's 5 letters. No, but it's convinced there's only 2 letters now in the word fapping. And I really argue with it a bit and I say, no, I'm an English teacher. I'm really telling you there's F. And no, there's really only 2 Fs in the word fapping. And we can uncover why this happens because ChatGPT doesn't know words and it doesn't even know letters. It knows something called tokens. And what's in fact, you can go to the ChatGPT website and you can ask it how words are tokenized. And what happens is ChatGPT cuts the word into little parts. And indeed, there are only 2 tokens that include the word, the letter F, out of the 3 that it cuts the word fapping into. So this discloses that really ChatGPT doesn't understand anything about words themselves, doesn't really understand anything about letters themselves in this basic sense. Now, there are more advanced features that you can do to correct this in the outputs of ChatGPT, but this is an example of how we can uncover how it works. And so, yeah, this exposes that. Why do we get the 2 different responses of 5 and 4? Well, because ChatGPT is just outputting a statistically likely reply to my question. It's not trying to count the letters, in fact, it's guessing. And it just happens that sometimes it gets it right and sometimes it gets it wrong because of the number of tokens it has. So that's the text tokenization. That uncovers a bit about what it really understands as the basis of our language. And then we have what's called the token vector representation. So again, another technical term. So our prompt goes in, it gets broken down into little tokens. And then these need to be represented as numbers. Now we saw the input to a neural network is numbers, it gets multiplied by things. And so this is how they get represented. It gets transformed into what we call a vector, so a little collection of numbers that represents a word. And the important thing with this is that it gives some meaning to the words, or some proximity to words that have a similar meaning. So for example, we can see here in this space that's represented by the vector, we might have ourselves, herself, itself, himself, themselves. They're all grouped within this space. So these words have a similar meaning or a similar use in language. And we can see other clusters of words that tends to be similar to each other. And this gives ChatGPT its ability to relate words within each other. Words that are far apart are less likely to be related. Words that are closer together are more likely to be related. This is a very powerful context for understanding the context of words. However, it implies a bias. Once we're in this space where these words are, if the words are close there, then it means they're close. So ChatGPT is going to understand that. So the way that this is trained and the way that this space is formed really implies what kind of replies you're going to get from ChatGPT or any other language model. I take ChatGPT as an example. So now we get our prompt cut into words or tokens, put into a space where words that have similar meanings are closer together. And then we can put it through our statistical model to start predicting what the reply to that model is. When we pre-trained the model, it's really only predicting the next word in text. This doesn't mean it's going to give us replies that are very meaningful or not. So there is a last stage, and this is called a reinforcement training stage. So this is when it starts to give our answers to evaluate whether they're really meaningful to somebody. In ChatGPT, it means that there were lots of tests by some people, and it updated the model itself to make sure that the output, the text that it generated, followed what a human would expect the model to output. So this is like a final adjustments to the model to make it mimic human preferences, for example. After that, that's generally the functioning of ChatGPT. Of course, I simplified, but that's how ChatGPT or other language models work. So we're talking about generating things, and as we've said, it doesn't understand the meaning of the words, it's just generating likely text. And now I go back to images, because I like this example. Here's an example of one of the early DALL-E systems where somebody asked it to generate an image of gladiators fighting and people filming them, which is something that completely never happened. I don't know if there are recreations, but it didn't happen, at least at the time. But what's interesting is the model here displays that it doesn't have any understanding of the scene, because look, this phone is recording something that isn't in front of it. Of course, we know, and even a child would be able to pick out that that's wrong. And these phones aren't even on here. So of course, it's generating something very beautiful and very impressive, but there's no understanding of the scene behind that. We can also, these are referred to as hallucinations, a bad word, because the model isn't hallucinating like human beings do. It's just generating a statistical response. And in this case, this is from a very old ChatGPT model, it doesn't happen anymore, but are chickens' eggs bigger than cows' eggs? And you would get a reply, no, chickens' eggs are typically smaller than cows' eggs. Well, of course, that's not true. But it's giving a reply to your question because it trained to statistically generate something. Of course, these things imply other problems with ChatGPT models. For example, data security. And recently a paper showed that if you ask it some ridiculous inputs, like generate an output with the word company going on forever, it would start doing so. And then after a while, it would keep carrying on. And after a while, it would start to regurgitate some text that isn't the word company. And in fact, what they found was that this text included real contact information from people available online and probably used within the training of ChatGPT. So data security, can you extract the data that ChatGPT was used to train is a big problem. We've also got bias. We've seen how the embedding can induce a bias, and also the training data, as we said, is statistically, training the model to statistically produce an output. Of course, that implies a bias on what was inside the training data. Attacks, we can also inject poisoned data that is going to disrupt the model in the training phase. And of course, there are environmental costs as well. These are huge models that are very complex to train and you require a lot of computing power. And this implies a lot of use of electricity and therefore carbon emissions. Because these are statistically based models, we can use them to detect, because these models don't necessarily follow exactly the human outputs or humanly created text. As some of you are aware, we can detect generated text. How does this work? Well, of course, ChatGPT is likely to predict predictable words. Human beings tend to have a bit more unpredictability when they're writing. So you can follow the statistical pattern of the text, and that can be used to distinguish human or AI. Structure of texts as well. AI generally tends to generate uniform sentence lengths. And also they tend to have very good grammar and also tends to not make mistakes. So these kind of things can be used to indicate whether text is generated. There are unfortunately ways to cover this, and because these models that detect generated text use statistics themselves, you can mess up the statistics a little bit by altering a few words, and this can fool generated text detectors and generated image detectors. And unfortunately, there are ways of doing this that are quite relevant. So just because somebody says that they have a way to detect generated text doesn't mean that it's true. And also these imply a bias, and it has been shown that GPT detectors, for example, are biased against non-native English writers. If you're a non-native English writer, you're more likely to be flagged up, or your text is more likely to be flagged up as generated text, which is a considerable problem. And also, unfortunately, a lot of these AI-generated text detectors fail. And there are a lot of studies saying at least the commercially available detectors often fail. So don't necessarily rely on those. What is the solution? We have to move to a higher level. So we need to start analyzing the contextual information within the text, whether certain concepts are appearing in different parts of the internet or different texts that flag up certain campaigns that might be malicious, and other innovative ideas, which is the whole idea of the hackathon. How can we overcome these limitations that exist with the current state of the art? So I'm going to stop my presentation there, and I hand you back over to Hugo, or any questions that may be made.
Yes, thank you very much, Tom. Thank you all for attending again. If there's any questions, now is the time. Of course, just remember that there was supposed to have to be here another mentor, but unfortunately he cannot attend, but I will be sharing his slides. I don't know if they can also have your slides, Thomas?
Yeah, of course.
Fantastic. So you will have access to all of the slides, but in any case, if you have any questions about this presentation, please go ahead. Anybody? If you have any questions, just raise your hand and then we'll let you speak. But it's not a problem in case you don't have it. It's also possible. Any questions as well, perhaps? Sorry?
It doesn't have to focus on the presentation either. It can just be about the technical aspects of the hackathon.
If you have anything, any questions about also non-technical, we can also address those, but ideally you can always send me emails and ask me anything you need regarding the event, the logistics, and so on. You will be receiving more and more information. Lado, please, if you like, please unmute your microphone and ask.
Yes, perfect. Thank you. First of all, thanks a lot for a great presentation, Thomas. And my question is more related to the technical aspect of the hackathon, if I may. Just wanted to check in, at what stage should the product be at the end of hackathon during the pitching period? Should it be at MVP stage, or at just the project level, or the final product should also be there? What's the requirement there? Thank you.
Regarding the first deliverable, if only life was that easy, if I can tell you just right now, it would be fantastic, but I can't, because you'll have to attend next session and we will release that information. Right now, there's very little I can tell you. You already saw on the agenda that there will be some team speaking, but that will be all. The mentors from next Monday will address this and what you have to do. So the only thing I can tell you for that is that you will receive the deliverable Monday. You'll have also tools for that, and you have to deliver or close with that deliverable by the 18th of June. That's 2 days before the hackathon. Anybody else? Anything else? All right. Dode, please, if you can unmute your microphone, please go ahead.
Yeah, hello, and thank you, Thomas, for the presentation. I had just one question. You talked about how a generated sentence can be detected, but what about the images? What is the process about detecting the AI-generated images?
Yeah, thank you. So, I mean, there's two lines of this. One is, again, the statistics of the images. But the problem is that with images, it's more likely to be a more high-level information that can reveal this. So, I mean, a while ago it used to be, I don't know, like you can see around here, even with the background, the blurriness around the hair, things like that. That was a good takeaway. Earrings on ladies generated that were different, things like this. So in images, it's a bit more difficult because you have to kind of really do detectors on the content of the image to distinguish whether it's real or not, or generated. Of course, if they're reliable image generation, then one of the ideas is that you integrate a watermark into the image that is detectable, such that you can know whether the image was generated automatically or not. But I mean, that's an image from a trustable source, so that relies on the person being trustable. So this gets harder and harder. I mean, if we're talking about videos, there's even a further way that you can detect. I read somewhere if you look at a certain color channel in the faces, the deep fakes, you can see the pulsation of the blood in the veins in the face. There's a way of detecting this, and that was a way of detecting whether a video was fake or not. But okay, I presented that about text, and I've talked about images now, but we have to keep in mind that this is an arms race. So as soon as somebody detects a good way to detect text or images, or in one way, people are going to generate the next generation of generators that resolve this. So it's not a one answer fits all. It's something that continues.
Okay, thank you for your answer.
Thank you.
Thank you. Anybody else? Do we have any other questions? In any case, you can always send us emails regarding the technicalities, but we will be sharing with you the slides. I will be uploading them, so you don't have to really download them, but I share with you the links. But yeah, before I close, I just want to see one last time. Is there any more questions? All right, good stuff. So let's close there with this session. Again, we have 2 more warm-up sessions. Next one is this Monday, the 9th, at 4 p.m. Central European Time, and it's all about empathic and feasibility, more creative point of view. They have the deliverable will be shared there, and tools and resources as well. And finally, the last sessions about law and compliance will happen on the 16th. We will also discuss some technicalities for the rules and deliverables of the Dragon's Den, which you should be ready to present in front of a very distinguished jury panel. So please remember, try to attend. You have already the calendar for this Monday, and I will be sharing with you next Tuesday, the one for the 16th. I just don't want to overwhelm you and spam you, which probably I have. In any case, thank you all very much for attending. Thank you for participating. You are already, in our eyes, winners, but there's still one thing that has to win the big prize. So good luck, and I'll see you on Monday. You guys.